Dear students, in the previous video, we understood introduction of chromatographic technique, and in this video, I am going to discuss in detail for UG students chromatography chapter. As you know, you understood the basic principle of chromatographic technique, and now we are going to discuss column chromatography. So in this case of chromatography, this is a basic form of chromatography in which the stationary phase which is settled retained in the column. In column chromatography, the stationary phase is a solid, so it's a porous material. It allows the passage of material through it, and the basic principle of this column chromatography, is also called as adsorption chromatography, because the mechanism of separation in this chromatography is adsorption, and the stationary phase which is used in the column chromatography, it is called as adsorbate. It absorbs the substance, analytes on it. So first we are going to dissolve the sample in a mobile phase or solvent. Then after that it is passed through a stationary phase, that is a porous solid. So these analyte particles get adsorbed or retained on the stationary phase, in the different extent, because each analyte possesses different physical and chemical properties. Because of that, their adsorption capacity also varies. If adsorption capacity varies due to their physical and chemical property uniqueness, so they are going to adsorb at different distance. You just observe here. So as soon as you pour the sample, here you found two bands. Here two bands indicates two different analytes. If you pour the solvent, just you can see the diagram here. So before the analyte, before it is a homogeneous solution, once if you poured into the column, it formed three different bands. Each band indicate analyte which are adsorbed at different position in the column. This selective adsorption, this is the basis for separation in case of column chromatography. Next, let us see the mobile phase which is used in the column chromatography. The important criteria we are going to use in order to choose the suitable mobile phase for chromatography is it must be act as solvent. It must be capable of dissolving the analyte into it. This is the first criteria, first property which is satisfied by the mobile phase. And secondly, it contains some developing agent. Developing agent means once the sample which is introduced into the column, it is appeared as a band of different color. Sometimes if analyte does not possess color, so this developer imparts the color to these analytes. So this mobile phase, sometimes it also acts as developer. And second one, and it also acts as eluting agent. That is, once the compound gets separated, the separated analytes which in the chromatographic column is extracted individually. The process of extraction of these analytes in the chromatographic column by continuous running of solvent or mobile phase is called as elution. The solvent which is used for the elution is called as eluting agent. So this mobile phase acts as solvent as well as eluting agent, and it must possess a stability and viscosity, and it must be easily detectable by a suitable detector, and along with that it must provide maximum resolution. Resolution is nothing but it's a separation, it's a band separation, bandwidth. okay, in a chromatographic column. So that is, it must be able to identify the each analyte, okay, by the different color which is in the column. So this is called as resolution. And some example, good example for the mobile phase which are used is, usually we are going to use ethanol, acetone, water, acetic acid and pyridine. Now let us see about stationary phase. You know, stationary phase, so which is fixed in the column, and in the column chromatography it works based on the property of adsorption. Okay, that's why it is called as adsorbate. And the separation efficiency of a stationary phase which is used in the chromatography, it is depends on surface area and particle size of adsorbent, because as I told in the beginning, it works based on the principle of adsorption. The adsorption, there are two factors which play an important, which affect on adsorption, that is the particle size and surface area. If surface area is more and if particle size is less, it enhances the separation, it increases the resolution of given chromatographic technique. So this is the condition we used to select a stationary phase. And the stationary phase, the solid particle should possess uniform shape and size in the range of 62 to 100 micrometer. And this stationary phase must be inert. It do not react with the given either with the mobile phase we are using or the analyte which is present in the sample. It must be chemically inert and thermally stable, and it must be resistant with acid and bases which are used in the chromatographic technique. And it should be colorless, inexpensive and readily available. So why? Because here in the chromatography we are going to identify the given sample based on their color. They are different color situated at a different distance in the chromatographic column based on their capacity of adsorption in a stationary phase. So if the stationary phase is color, it is difficult to distinguish the given analyte. That's why it must be colorless and it must be economical and it must be easily available. This is another condition. And it must good separate the various compounds. And the well-known stationary phases used in the column chromatography are silica gel, alumina, charcoal, calcium carbonate, calcium hydroxide and magnesium hydroxide, etc. Now let us understand the experimental procedure of these column chromatographic technique. In the column chromatography, the first step is we are going to prepare the column. So the column preparation is very important, because the preparation of column it decides the resolution and separation efficiency. So for that, what we are going to do is, so just observe in the figure. You can observe in the figure. So this is a column. So this is like a test tube. Okay, not test tube, sorry. This is like a burette which is used in the volumetric analysis in the laboratory. Here, so first we are going to clean this chromatographic column of length nearly 40 to 50 centimeter. We are going to clean this and we are going to fix the carton at below this chromatographic column, and then we are going to, so here we are going to prepare a column by two methods, wet method and dry method. In the wet method, we are going to prepare a slurry. We are going to prepare a slurry of a given stationary phase. Then we are going to add packed into the column without air gap. Otherwise, first we are going to fill a solvent or mobile phase into it. Then we are going to add the anhydrous solid stationary phase. So we are going to pack the column without air gap. So this is the first method of preparing the column. And second method is running the sample. Once column is prepared, So we should not allow the column to dry. So it always wetted by the given mobile phase. After that, we are going to dissolve the given sample in the mobile phase, and we are going to injecting the sample, okay, to the bottom of the at the bottom of the column like this. So once we are introduced the sample, so then we are continuously pouring the solvent, and the components, the analyte which is present in the given sample started separated. So once first we are going to dissolve the given sample in a suitable solvent or mobile phase, then we are going to introduce from the top of this chromatographic column, and afterwards, so we are going to continuously passing mobile phase. On continuously passing mobile phase, these components are absorbed at a different extent. So this is the second step, and so this is a third step. So on running the on continuously passing the mobile phase, so you just observe the various stage here. Various stage. In the first stage, the separation is less. So if it goes on, what happen? So these analytes are completely separated, and they are situated. They are situated at different position. You just observe here. Each color indicates each analyte, and these analytes are located at different parts of chromatographic column. So this is called as development of chromatogram. That is the process of separating the given analyte and to form different bands in the chromatographic column, and this is called as development of chromatogram, and this is called as chromatogram. And once the chromatogram is developed, then so step 4 is elution. Once these separated particles are eluted, so you can observe so different steps in the elution here. The one which is loosely held by the stationary phase comes out first, and the one which is strongly held by the stationary phase comes at the end. If you look at this chromatogram, the blue color, the red color, and the yellow color. The yellow color analyte which is loosely held, that's why which is in the bottom of the chromatographic column, and the blue one which is top of this chromatographic column, that's why it is situated at the top. And why? Because it gets strongly absorbed to the given stationary phase, but it is loosely absorbed, the yellow one. That's why on elution process, yellow comes first, then red, and then blue color. So this is elution. So once after completing the elution, we are going to ensure whether the separated components are pure or not. This can be ensured by passing the eluted separated components into a detector. So just you observe. So once if you eluted, you are going to collect in a separate vessel, then you are going to pass it to a detector, and so by using detector you can identify its chemical composition. So this ensures that the separation, this is ensures the separated components is pure. So these are the various steps of chromatographic column chromatography. So next is applications. So by using this, so we can extract compounds from the plant, and it is also this is used to separate geometrical and diastereoisomer, and this is also used to extract liophobic substance like lipids and steroids, and it is used to determine drug estimation, and it is used to remove the impurities, and it is used to isolate metabolites, and it's used to identify and purify the end product in organic synthesis. Like that, many applications are there that you can learn. So thank you for listening my videos. So you can interact and you can clarify